First, let's get started off with some basic equations. The first one can be used to find either the focal length, the distance of the image, or the distance of the object, and the second one can be used to find magnification, the height of the image/object, or the distance of the image/object. Make sure you remember that magnification is always positive, which I did on the test. Now here are some basic properties. Virtual means that light rays do not converge on the image, while real means the opposite. As for orientation, erect images are right side up, while inverted images are flipped across the horizontal axis, and perverted images are flipped across the vertical axis. Size should be self-explanatory. Now, let's talk about the properties of images formed by different mirrors/lenses. In the case of plane mirrors, a virtual, erect, and inverted image is formed. The image is the same size as the object. For convex mirrors, a virtual, erect image is formed and the image is smaller than the object. Images formed by diverging lenses have the same properties, but they are located on the object side of the lens. For concave mirrors and converging lenses, the image is real, inverted, and smaller if the object is farther than C, and real, inverted, and larger if the object is between C and the focal point. There is no image if the object is at the focal point. The image is virtual, erect, and larger if the object is closer than the focal point. Also, if the object is farther than the focal point, the image is on the same side of the object, and if the object is closer than the focal point, the image is on the opposite side of the object. This is vice versa for converging lenses. Now, let's go on to refraction. If a beam of light is shined from a more dense to a less dense medium, the angle of refraction is larger than the angle of incidence and the light is refracted away from the normal. The opposite is true for light traveling from a less dense to a more dense medium. The specifics of the angles can be calculated by using Snell's law. If the angle of incidence is large enough, the refracted beam is parallel to the boundary. This angle is known as the critical angle. If the angle of incidence is larger than the critical angle, then all the light is reflected. This is known as total internal reflection. And now let's wrap this up by talking about mirages. These typically occur in hot days and are the result of heated ground heating the air just above ground at higher temperatures than other air. This leads to the creation of a non-uniform medium which stops light from traveling straight. Because light traveling into the less dense air speeds up, the direction of the light changes and causes the ray to bend away from the boundary. An example of this in action would be a person looking downward at the ground and seeing an object just located above the ground.